What if I told you that some of the most dangerous software flaws look completely normal at first glance until it causes a crash, a leak, or a security failure? Every day we rely on software for almost everything: communication, banking, transportation, healthcare, or even national infrastructure. So when a hidden vulnerability slips into the code, the consequences can be serious. A small flaw in the wrong place can lead to data leaks, system crashes, or even security attacks. So, my research focuses on how we can detect those hidden risks earlier before they turn into real world damage. For that, I focus on Rust, a modern programming language which is considered to be safer compared to the other traditional programming languages like Python, C++, Java. But safer doesn't mean perfectly safe. Vulnerabilities can still appear in complex part of the program. So, looking at the surface of the code, both programmers and scanning tools may miss deeper analysis. So the question is how we can help computers to detect those hidden patterns effectively and earlier. To answer that, I do not look into only the surface of the code in one way and compare three different views of the program. The first one is the source code written by the programmers or the developers. The second part is an intermediate representation, which computers can perfectly understand. And the third part is a code property graph. That is, think of a graph or almost like a map showing how different parts of the program interact, connect, and influence each other. And that matters because vulnerabilities often hide in relationships, not in a single line of code. So the story is pretty straightforward. Looking at the very first step to the very end, we can see those hidden risks can be found before they become threats. And that is at the heart of this research. I am training essentially a machine learning model that is a type of AI that learns patterns from data to look beyond what code says on the surface and instead understand how it behaves underneath. The goal is not just to find bugs faster or earlier, but to find the kind of bugs that are easy to overlook and expensive to ignore. In the bigger picture, this research can support stronger software security and reliability, more reliable systems, and earlier warning signs for developers. Because in cybersecurity, the most dangerous problems are often the ones we do not see. And my research is about making those invisible risks visible. Thank you.